All right, let's continue with our first subdivision of Tracheophyta. When you see the subdivision, it's always ended with Opsida. So if I ask you what subdivision it is, the first thing you can do is write down Opsida, and then you figure out what to put in front of them. So all subdivision end with Opsida. So let's talk about the first one called Psilopsida. So you is a silent P. So it's just pronounced Psilopsida. So this character of the group is the first group that have sporophyte being dominant in the group, and then now they start to have the true vascular system only in the stem, and in the root or the leaf there's still no vascular tissue. So when I say real, there's no real root or leaf, meaning no vascular tissue in those organs. So if you look at the root or the leaf, you don't see the vascular tissue in that part. You just see like tissue that look like root or leaf. It's not the real stuff. And then the key characters here is dichotomous branching. So when you see the branch, they usually go like 1 to 2, 1 to 2, just like this, 1 and 2, 1 and 2. So this kind of branching is called dichotomous branching. Dicho mean twice, tome mean separate. So it's separate to twice, to like to two different things. And this group produced homospores, like they produce only one size of spore, and in the adjective form we call them homosporous plants. So this is the homosporous plants, which mean they produce homospores. Okay, so let's have a look at what they look like. So oopsie. So this is the only genus in this subdivision I want you to recognize. This is called Psilotum. So this is a genus name in case you don't know that yet. So this is the genus name of this group. The English name is called whisk fern. If in Thai we call them whitenoi, is really characteristic. You see this dichotomous branching over and over and over again. So you will only see the vascular tissue inside the stem, not in the leaf, not in the root. So let's look at the vascular tissue here. It's very simple, very rudimentary. You see like a bunch of xylems and phloem. Like in here, this is xylem and this is phloem. You don't have to know that right now. Just I want you to see that they actually have vascular system, but it's really simple one right in the middle. So the key character here is that they don't really have a leaf, but they have this humongous sporangium. So this is where we produce spore, and they have the special name called synangia. Syn, syn mean together, and angia comes from the same like angium, because this actually three sporangium fused together like this. So this like 1, 2, 3. If you look from the top view, it look kind of like this. Weep, weep, weep. 1, 2, 3. So there's like three component like fused into one. That's why we call them synangium. And this sporangium sit on top of what we call leaf-like scale. Leaf-like scale, because it's actually not a leaf. It looked like a leaf, but it's a scale. It's just like a little bit. If I try to zoom in here, let's see if they can get any bigger. So if I try to zoom in, here we go. I love this stuff. So if you zoom in here, you see that oops, sorry. Here we go. Okay. You see you don't see what I see. Sorry. So if you look around here, you can like pause and zoom here. You can see that there's no vascular tissue inside here. It's just like a plant tissue, just like flat tissue. There's no vascular tissue here. That's why they don't call leaf. There's no vascular tissue here. So which is confirmed by the next slide. So I do the long section. If I cut a plant on lengthwise, you see that this is the scale like leaf. Scale. Oops, sorry. Leaf like scale. This is leaf like scale, and this is the sporangium or the synangium that we talked about earlier. The sporangium, they have like multiple chambers in there, and inside of this is the spores. So the spore is, you can see only one side of spore appear here. So this is the homospores. So you can see that they have some vascular tissue right in the middle of the stem, but not elsewhere, not in the leaf-like scale here. So just like a plant tissue just supporting the sporangium. And the gametophyte phase of xylotum are really, really tiny. You can see here is like 1, 2, 3, 4, 5 different 5 millimeters, like half a centimeters, and it's underground. It look kind of ugly like this, and this is their antheridium and achigonium right on top of them. So we want us to recognize this is like super uber tiny. It's really small, and that spore you see earlier, that spore would germinate into this, and this would produce egg and sperm, and right away reproduce and give the young gametophyte or young sporophyte again. So this is the summary of what the life cycles are. So it starts from having the spore in the sporangium, right? And the spore in the sporangium germinate and give rise to the gametophyte, and this will produce what egg and sperm, and egg sperm will fuse, fertilize, give rise to zygote, and they become young sporophyte, which when they grow later become mature sporophyte and give rise to sporangium, and they keep going around and around and around. And you see this new word here, the ination. It's the same thing as leaf-like scale. It's just different word for it. So this is Psilopsida in a nutshell. So I'll pause here so that you can have a break. I know it's a short clip, so that way you have feeling more inspired to watch more. If you have something else going on in your life, you can stop and you go do something else. So we're gonna try to keep like each group into one clip so that you can come back to review them one after another without having to go through the whole thing. So let's stop here until we come back to the next clip.